My name is Janine, and I work on Cesium for Unreal and Cesium for Unity, as well as Cesium Native, the backbone of all of our integrations. And in this hour, I'll walk you through how to incorporate 3D geospatial context using Cesium's Runtime plugins to build digital twin experiences for the natural and built environment. So in the morning, you got a taste of building geospatial apps for the web with Cesium.js, as well as how to upload and stream your own data with Cesium Ion. So what is the mission of the native runtimes? Well, we at Cesium are proponents of interoperability and growing the geospatial ecosystem, and we want to enable people to freely bring in their data and create apps in the environments that they're most empowered by. That's why we've worked to build several free and open source plugins for engines over the years. And the point of these integrations is to unlock capabilities. This was a video, but that's OK. The point of the integrations is to unlock capabilities in engines that are largely powerful on their own, but may not be equipped to handle full-scale, accurate 3D geospatial data. So Cesium brings these geospatial capabilities to the table, while at the same time taking advantage of the engine's own features, such as physics, character, and vehicle controllers, foliage, and rendering power. And developers can also take advantage of plugins in the engine's ecosystems themselves and combine them with Cesium, such as immersive sky and weather systems. We only have an hour, so we're going to focus on how to use Cesium for Unreal today, but these workflows and concepts are going to carry over across all of our runtimes. And now that I've done my intro, we'll do a half-hour deep dive into the basics of how to use Cesium for Unreal. I'll be joined by some TAs on the side, so please feel free to raise your hand and ask for help. Ryan's over there. We have Kevin, Cory in the back. Definitely feel free to ask questions as I go along. Feel free to tell me to slow down if I'm moving too fast. We'll all do our best to help. And then after this part, I'll showcase some other cool features that we provide. This is going to be more of an overview and not a walkthrough, but you can look up the tutorials for these on the Cesium website, and I'll have them linked in the slides. And I've also accounted for 15 minutes of free time, so you can explore any of those additional features or the other samples in the sample project, or ask me more in-depth questions. So this time is early for you. So the required materials for this are the Unreal Engine 5.3 or later versions. Cesium for Unreal Samples project, hopefully you had that downloaded and open before this part, because it tends to take a while to compile the shaders. There is also a text file called the Cesium for Unreal Workshop Materials, and that just contains some convenient copy-paste values for when you're putting stuff in the level. And then we have some local sample data just as a backup in case the internet isn't strong enough to support everyone streaming. But hopefully it does. All right, so we're going to start, and I'm going to try and handle Unreal Engine on the side at the same time. So first, let's create a new level. Here, I'm trying to see how I can easily switch between these. OK, so first, you're going to create a new empty level in the samples project. You can go to that by File, New Level, and then select Empty. And if you see a black screen, that's good, because that means the level is empty. So switch over to that. So File, New Level, Empty Level. Great. Great. It's also a good time to save the level and name it, and just keep saving as you go along, just in case you lose a little bit of progress because of some undo history stuff. Next. I'm trying to go next. OK. OK, well, then we want to add a Cesium Sun Sky. So this is a wrapper around the Unreal Engine lighting system. It's going to provide like a realistic day and night lighting system. So we're going to go over to Window, Cesium, and open that. And you should see this appear on this side. Trying to expand that. And then I want you to click the second option, the Cesium Sun Sky, and then there should be light. So this is going to help us be able to actually see what's going on in the level. OK, now Steven's already signed in on his laptop, but you're going to see in the Cesium panel that there's this blue Connect to Cesium Ion button. And hopefully you all have a Cesium Ion account from the previous workshop sessions. So you're going to want to click the Connect to Cesium Ion button, and then authorize Cesium for Unreal to access data in your account using the blue Allow button. Are there any, do I need to repeat any steps for anyone? No. OK, I'll keep going then. And now we're going to try and test our internet and stream Google photorealistic 3D tiles. So you'll want to, once you've authorized your Ion account to be accessible from Unreal Engine, you should see this list of Cesium Ion assets pop up on the left sidebar. And you should see Google photorealistic 3D tiles as a second option. And if you click the plus icon next to that, you should start to be able to stream data if internet provides. It might not. It's happening out there. That's great. OK, as long as it's happening for somebody. I'm not sure why. Let me try. I'll try streaming Cesium World Terrain instead. OK. OK, I'm going to use a different data set so that I can stream it to you guys. But hopefully you have Google photorealistic 3D tiles streaming on your end. All right. I want to make sure that people at least can see some terrain in their level before I move on. Seeing some nods? That's good. Some thumbs up? OK, awesome. All right. Now this is where we get a little bit technical. Now that we have a globe streaming in Unreal Engine, well, how do we build a level around it? How do we deal with the scale of the Earth and the fact that it is round? In order to do that, we'll need to first understand the concept of georeferencing, which is a core concept to all of our runtimes. And this diagram is a really big simplification because, of course, the engines are 3D and use 3D coordinate systems. But it illustrates how game engines aren't typically configured to work with a round globe. They're usually programmed for environments that are continuous along the same plane, right? So even if your level has valleys or hills, it's going to continue to stretch out on the same plane, and the game will always see your direction of up or down as the same. Gravity will always point down, you remain upright, and all the physics work well. Well, that model, oh no, imagine there's an Earth there. That model doesn't hold up when you have a full globe in your scene. So imagine that you're sitting at the center of your level somewhere in North America, and the orange arrow is your up direction, the green is your right. If you want to stay in this area of the globe, you shouldn't have too many issues. However, if you imagine that circle continuing down, and you imagine you wanted to travel to another continent, suddenly things don't make sense at that part of the world because the Earth would appear sideways, and you would be falling off the edge. So you actually should be like this on that side of the world, right? But it gets even more complicated if you're going all around and you want to make sure your sense of up is the same. So how does this reconcile with the game engine where it's expecting your sense of up and down to be the same? Well, this is where the georeference component comes in all of our runtimes. So if you want to take a look at the georeference component in the scene, it should have been added automatically over here. Let me open that for you. And you should see, if you go down to the details, that you're going to find this longitude, latitude, height definition. And currently we're positioned somewhere in Denver, so you're going to see a bunch of hills here. If you imagine some 3D math for a second, you can see this like coordinate system in the middle. This is located in the center of Unreal Engine's world. So what Unreal Engine thinks is 0, 0, 0, and it's X, Y, and Z axes. If you could imagine me going along this red arrow all the way far away across the Earth, at some point, I'm going to start leaving the Earth's surface because it's going to curve away. So what the georeference does is it accounts for where on the Earth you want to be and makes that the center of the Unreal level so that you maintain that global awareness while still having these like local game elements. So as long as things stay in relatively the same area where the Earth won't curve that much, a player wouldn't notice. So now that we want our level to be based in a different location, we should set that on the georeference. So these coordinates are available in that text file that we provided to you. You can copy paste those in your editor. I'm going to do that manually over here to set this. All right. And you should start to see the world shifting because you're traveling to a new location on the globe. Okay. So do people see a change of scenery here? So we're somewhere now in western Pennsylvania using these coordinates. So that's the kind of view you want. Oops. Now it's also possible to move the georeference at runtime, but we're going to keep it pretty simple for this demo. But you could imagine moving this around just so you can actually keep your character or your player upright while they're moving around the scene. And now let's add some additional data on top of our global terrain layer. So we have a sample tile set called Snowden Towers. It's been tiled by our design tiler, and it features some architectural elements. And this is a common use case for us where people want that real-world context, but then they have a building proposal, or they want to visualize a bridge, a road in the context of what's already there. So in order to do that, we're going to add a completely new tile set. So if you go at the top, you should see blank 3D tiles tile set. If you click the plus sign here, that should open a new Cesium 3D tile set. And if you go to, this number is in your text file for the workshop materials. You can copy paste this ion acid ID into the relevant field underneath the tile set. So let me do that now. Okay. Well, there you go. Okay, so now you should see this architectural building in the middle of your terrain. So we want to see both Earth and building. I can pause right here if there's any questions or if people want to catch up so far. How do you move the location? So do you mean the georeference part? Yes. So there should be a georeference object in your level right here. So if you go to the details panel and scroll down, there's going to be this origin, latitude, longitude, and height. And these values I put in the text file so you can copy paste them. But if you want to type them from here too, feel free. Yeah.
Sorry, I missed the beginning. Is this in IAM already, or do you have to add it to it?
So a data set can itself can contain the coordinates where it's at. So this particular tile set does know where it's at. Yeah.
I just mean this asset.
Oh, this asset. Yeah, it should be from Cesium Ion already. It's like a sample data set that we allow people to stream for testing purposes or just to like show off the capabilities. Yeah.
I just loaded it up and it said it wasn't allowed.
Oh, do you have the, is there, you downloaded the samples project, right?
We're doing it in there.
I did put a token in there to automatically authorize it. But if you have the samples project, you can steal it, this token, and yeah. Yeah, of course. Oh, my effort to make things simple, I might have made it more complicated.
Missed the beginning.
That's okay.
Thank you.
Yeah, of course. Okay. I'll move back. All right, and we're going to do one more data set below it. So this particular building also comes with a sample site, which kind of shows the greenery and the parking lot that goes along with this building. So you can follow the same exact process to add that to your level. I'm going to add a tile set, and I'm just going to name this one, actually. You can double-click the name to rename it. I'm going to name it sample site, just so I know which one is which. Snowden Towers. Okay. Again, going down to Ion Asset ID here, and typing it in for the sample site instead. 129. And there you go. That should pop up. So now we have this sort of proposed building site in the middle of existing context for Western Pennsylvania. Yep.
I noticed you changed the names of the.
Yeah. So if you click on the object in the hierarchy, you can double-click this name and then name it something helpful. Yes. Any other questions for me so far?
Just a follow-up question. I didn't see that it. Were you just adding the asset ID?
Oh, yeah. So I can repeat this here. So first, you add a blank 3D tile set from this option. And then scroll down. You should see this asset ID field. And then I included the IDs in the text file that I shared with y'all, but you can also copy it from my screen if that would be easier. So, like that. And then typically you need a token from Cesium Ion, but I tried to set it up so that the sample project already had a token that authorized access to this, so hopefully it's all streaming in just fine. Okay. So you're going to notice that in this particular scene, the proposed site is conflicting with some existing surroundings. And this is a common use case, especially if you have, an existing abandoned building that you want to replace with a new one, or you want to see how like a infrastructure can be carved out of the terrain to transport people from one side to another. In order to do that, we have a feature in Cesium for Unreal and our runtimes called polygon clipping. And what this does is it lets you specify a polygon area where you will hide the existing data. So in order to do that, we're going to create a cartographic polygon. And this should also appear in your left sidebar under Cesium cartographic polygon. So let me do that here. And if you double click it in your outliner, it will zoom out to see it. I always forget I have a screen here. And this is, this acts like any other Unreal object. You can transform its location, rotation, and scale so that it better fits the area around the data set. So what I'm going to do is first, we want to edit this polygon so that it fits around the sample site very cleanly. So it will help if you hide the existing data. I'm using a different data set so that I stream more fast, but if you have Google Photorealistic 3D tiles, you want to click that eye next to it, and that should isolate the data that you just added in. Then I click back on my polygon. And if you see this gizmo, you can move the polygon so that it is closer to the data. You could also rotate it. So if you press the E hotkey, it becomes a rotation gizmo instead. And then the last hotkey is R for scaling. And this might be familiar controls if you've used a 3D program before. And then for more granular edits, you can double-click any of these, press W to move, and then adjust these accordingly so that they better fit the data. So I'm going to do this super quick. All right, that's good enough. All right. Any questions for me so far? No? OK. So then, now we need to actually connect it with our tile set in order to tell it, hey, I don't want to show any data here. We do this through a raster overlay. And what a raster overlay is, if you can imagine like a 2D map image and make it drape over the world, it's sort of projecting that imagery onto the 3D surface. We use that to take the polygon and tell the tile set, hey, don't show anything here, so that you get this nice clean cut out of the land. So first, we're going to add a polygon raster overlay to your data. And you can show it again by toggling the visibility. If you see this add icon, it adds a new component to the actor. And if you search polygon, should be the only thing there. So click that. And then you'll notice that there's a handy polygons array underneath in the details. If you add an array element and click the None button, it will filter out to find the polygon that you just added. And suddenly, it disappears. And you can fully see your sample site. And this kind of technique doesn't just get used for clipping away terrain. It can also be used to apply colors to regions, or to even replace this cutout with generated geometry so that you have an actual mesh there that you can do other stuff with, like generating procedural content. So it's a pretty nifty tool. It has a lot of versatile use cases. Yep?
You're stitching up, like basically stitching a local tile set into this global.
Yeah. And so, yeah, there's a lot of different use cases for it. Like, but for this particular like AEC use case, it helps to have existing surroundings. But then, sometimes your project will like change the terrain, or it will do something where you just see these geometry conflicts. And so this is a nice way, easy way to just kind of clear that away so you can fully see your data. Some people have also used it to like highlight certain regions. So like instead of applying a transparency effect, they can apply a color so that it draws attention to it. And Stephen will even talk about a use case where after the terrain is clipped away, you can generate Unreal meshes. So you can generate like a grassy field that feels it. It's pretty cool, right? We didn't come up with that. He came up with that, but. But yeah. So there's a lot of use cases for sure. Thanks. Good question. Any other questions? Yeah. Yeah. So Unreal has like movement tools. So if I click my object, let me find it again. If I click on this, the W key is what brings up this set of arrows. And so I can adjust it that way. There's also the E tool for rotation, and then this scale for that's brought up by R. So that should help you physically move the polygon to the correct location. Okay. Yeah. I'm so sorry?
You added the Cesium cartographic polygon using the add function, right?
Yeah, we try to make this as simple and easy as possible. So there's an Cesium cartographic polygon option here that just lets you drop it into the scene. Yeah. Okay. Any other questions? No? Okay. Well, if you followed along, thank you for your attention. But yeah, here's the steps I did where you connect the polygon. But otherwise, that should be done. So congrats, you've just completed a walkthrough of the basics of the AEC workflow in Unreal Engine with Cesium for Unreal. Now, of course, this is not everything that our plugin can do. We have a lot more features that we have. I don't have time to walk through every single one of them in detail, but a lot of these are demonstrated with our samples. So if you have the Cesium for Unreal samples project loaded, you can actually click through the samples and check out for yourself what these do. So to build on the concept of georeferencing, recall that a georeference sets a specific point on the globe as the center of the Unreal level. Every object that is created through Cesium will account for this georeference and position itself somewhere on the globe accordingly. But Unreal objects don't know that by default because they don't have to care about the globe for a typical game. So let me demonstrate what happens if I add a cube to my level. So you'll see that my Cesium georeference is at 0, 0, 0 in the world. If I add let me go to the place sectors. Yes. All right. So I'll add a cube to my scene. Let me make this really big. All right. So I have my really big cube. Actually, I'll make it a little bit smaller. Now, I know I'm using a simple cube, but imagine that I'm trying to spruce this up. I'm trying to add maybe some trees, maybe some cars in the parking lot, just other objects to really flesh out this digital twin. So I'll add this cube here. OK, and I would like it to stay there. I would like it to be built on this grassy area. Now, imagine I want to shift to a different site, somewhere a little bit farther away. So OK, let me put my georeference, let's say, over here. Where did my cube go? Actually, it kind of came with me. And that's because it is only defined relative to Unreal Engine's 3D coordinate system. So we've just moved Unreal Center to be at this new location, but my cube doesn't know that, so it's just trying to follow me along. If there's ever a case where you have an object that you want to have global awareness, a specific longitude, latitude, height, position, you're going to want to use something called a globe anchor. So let me undo. OK, so let me go back. So you can add something to your objects called a globe anchor. And that'll look really similar to the georeference, actually. It's got a position that's longitude, latitude, height. And anytime that you move the georeference, it'll automatically, oh, I put it on the wrong thing, excuse me. I put it on the, so let me put that on the cube instead. Globe anchor. All right, so now this cube has a assigned longitude, latitude, height position. I can move a long time away, place my georeference, and my cube has stayed in the same place. And so people use this a lot to keep things not only just anchored to the globe, but also aware of where they are, so that if, say, you're going to the other side of the Earth, you can account for my curvature changing so I can stay upright, or other sort of effects that would normally work in Unreal space. So that's globe anchors. Another alternative for building Unreal levels is sublevels. If you've ever used Unreal Engine or another game engine that has sort of like level streaming, sometimes they break up stuff, big levels, into instances. And as a player moves into that instance, it will start to stream it and unload stuff it doesn't need. So Cesium for Unreal tries to play into that, where if you have a ton of objects in one localized area, and adding a ton of globe anchors would be a little tedious, you can instead say, I have a sublevel at this specific longitude, latitude location, and whenever a user goes in and out of its radius, it will activate and deactivate objects. So it should feel pretty familiar to an Unreal game developer who's already working with Unreal level instances. It just happens to have coordinates assigned to it in a globe relative space. And also, you could see this behavior in sample level 4 called Cesium sublevels, and that will kind of have a sample where you can fly between locations on the globe, and stuff will pop in and out depending on where you are. Controller in physics. Sample level 3 in the Cesium for Unreal samples has a person running around on some photogrammetry, but basically all of our data sets that can be streamed through Cesium for Unreal can interop with physics. So you can actually run around on terrain or on streets as they stream in, and it doesn't just have to be third-person human controllers. It could also be vehicles driving along roads. It can be drones or planes flying over. One of my favorite examples of Cesium for Unreal with unique controllers is this user story by Fluid Planet, and they actually designed a kind of a game for kids that lets you play as different animals and explore different biomes. So you can play as a bird and fly over Cesium world terrain, or as a fox exploring this forest. So you can get really creative with these. Foliage. So to spruce things up and add some photorealism to your scene, you can use Unreal Engine's foliage painting tools to add grass and trees and leaves. And finally, Cesium for Unreal also lets you use materials with tile sets, so you can add these really cool effects like a height map or lines, water effect materials if you're near a lake or another body of water. And if you're working with tile sets with metadata in them, so kind of like this example here where I have the San Francisco ferry building, and I want to visualize the different parts of it. Well, this particular data set comes with metadata that lets me colorize those different features, so you can kind of break down the overall model into smaller visualized features. OK, well, that's it for the guided part. Honestly, there's a lot of free time. Feel free to explore the Cesium for Unreal samples if you have it downloaded, or you can just use this time to ask me questions about any of our runtimes. But yeah, thank you for your attention. Yep.
Did you have a background in geospatial mapping before you?
No, I did not. I wanted to work in video games, but I found a decent compromise working with game engines, and I think geospatial presents an interesting problem because the scale and kind of the awareness and the accuracy that you need, so it really changed my perspective on like how cool the technology is. Yeah. Yep. Twinmotion? I don't think we have an official tutorial, but I know that people have tried to use it before with Twinmotion, but I don't have any personal experience. Yeah. Okay. Yeah. Integrate elevation levels? What do you mean by elevation levels, I guess? Like,
Say the train is visually loaded, which is very flat.
oh,
What's the elevation of the train?
yeah, that should be included. So it's not very clear from this example, but if you kind of can see, like, it's got elevation built into it. So we actually are 3D first. We don't do flat. We didn't do flat right away. We added it after the fact because people asked for it. But this is all this is all terrain, real world height map terrain. Yeah. Okay. Yeah.
What's the best way to get the height of the terrain from something?
That's a good question. So we actually added an API for this. So Blueprints is kind of a visual scripting method in Unreal. And we have this sample height function, sample height most detailed. And so if I have a tile set in my level, let me say Cesium world terrain. There you go. So if I want to, for example, place objects on the terrain at runtime, I can use this to basically pass in some longitude, latitude positions. And then the result of those will have the heights that place it precisely on the terrain. So that's a good procedural way to place stuff on the ground. Yeah. Yeah. Thank you. It's a good question. Yeah. Sorry. Oh, okay. Yeah, I mean, it's just free time, so I'm just chilling. Okay, cool. Yeah, sure.
You don't have to demo all of it, but what are the general categories of how to access metadata? Like you can click on objects.
Oh, that's a good.
Where can you access this?
Yeah, I can demo that. So let me see your content drawer. So Steven suggested I demo something having to do with the metadata systems. And this is the sample level that I referenced in the slides. So we have this model that is colorized depending on the features inside of it, and I'll get to those in a moment, that kind of system in a moment, but as this is loading in. So a feature that we have is metadata picking, where if a user sees a feature in the tile set and they want to learn more about it, they can click and see certain types of information. So this one's pretty simple. It just tells you what kind of component it is, and there's a color assigned to it to visualize it differently from the others. But as I'm clicking on these features, you can see, oh, that's a window, that's a pillar, that's a wall, so on and so forth. That's the roof. And there's a lot more complicated like use cases, of course, where there's a lot more metadata per building, like height, population, what building type it is. So people can pack a lot of useful information into these data sets and then extract them at runtime. And then this metadata styling aspect, where the colors are transferred to the Unreal material layer. So yeah. So Unreal Engine has a material system with material layers, where you can create these kind of graphs from nodes and tell it to do something with that information. So this is just passing in that metadata from the model into a way that you can interact with it in the shader. So I'm literally just saying render the color from the data set. I could even like demonstrate, actually, dare I compile shaders in real time? Let's try it. Yeah, let's see what happens. You know. So this is just, here, let me do a more obvious color. And then let me see. Yeah, so I kind of have this Uber shader with a base material and then my thing added on it. And I'm just showing off like how you can apply different visual effects. Is there an opaque? Okay. All right, I'll just change this then. So it's basically just harnessing Unreal's material system to apply whatever effects you want. I'm just recompiling. So I can this is a kind of a very bright example, but I can really just act on whatever colors are in there and in the metadata and visualize them. You could do stuff like visualizing height across an entire data set with a color gradient, or hide or show features. Actually, let me show you a more interesting AEC example if it will load. Let's save. And let me fix what I just broke. Sorry. Nope. Cool. There you go. Sorry. Plugins. All right, let me fix this to what it was before. Okay, there you go. So this is a really elaborate example of metadata. And so if you click on, this one is programmed so that if you click on something, it'll highlight that feature. It gives you way more information about what's in that. And for AEC applications, people like to take a sample model, kind of explore like what are the materials for this location, or what kind of thing is this. So that's what all these numbers correlate to. And you can also toggle the different areas of it. So I can remove the facade and the architecture, and you can see these floors inside. You can see even like the HVAC systems, the electrical, all that cool stuff. So this is another cool use case for that. Another sample level with the same data set. Oops. So if we go to 14, that's 14. actually. Oh yeah, so this one also shows the hiding of that, but I want this one. Okay, so this one's cool because it shows a kind of more advanced example of metadata styling. So this one lets you filter all the pipes in the building by their length. And you can see the ones that are red that fit this kind of range. I can dynamically change that to see what are pipes of certain lengths. So these are the kind of like dynamic interactive experiences that the plugin can empower just for like analysis or convenient visualization of certain features of the data. But yeah. Oh yeah.
What kind of pre-processing was done before the model was added?
Yeah, so this was I think an IFC model, if I want to say, that was run through our design tiler and Cesium Ion. And IFC models have a lot of metadata that are attached to each individual component of the building, like what is the material of this, what type or family of products is this window made of, and that gets preserved through Cesium Ion's design tiler and just streamed as 3D tiles in here. So it takes care of that like kind of packaging of the metadata for you. Yeah. Cool. You can wrap it up? Okay. Yeah. So if everyone is finished and has no more questions left for me, we can just wrap it up early. Especially because I need to give back Steven his computer. But yeah, thank you so much. Appreciate it.